Angle of repose. Angle of repose is the minimum angle of inclination of any plane with the horizontal, so that the body resting on the inclined plane tend to move down the plane, and that minimum angle of inclination is called as angle of repose. So in this diagram you can see that this theta, if the body which is resting on the inclined plane, if it just slides down, then that angle theta is called as angle of inclination. Whenever we have objects on inclined plane, the forces acting on the inclined plane, how to represent them, they are of importance. So first of all, the first force which we have to show on the or in the diagram is the weight which is acting downwards. Okay, so the weight is acting vertically downwards, and normal reaction will always be acting normal to the surface of that inclined plane. So it should be normal to the inclined plane. That way the normal force is acting or normal reaction is acting. Okay, so these are the two forces acting, and how this body is coming down, let's discuss that. So once again we have that inclined plane. So in this discussion we have taken phi as that angle of inclination. Now as we discussed mg, the weight is acting downwards and normal reaction is normal to the surface of the inclined plane, and here we have resolved mg into two components. That mg is resolved into mg sine phi and mg cos phi. So here first of all we have defined phi as the angle of inclination, so that this angle also comes as angle phi. So there is a theory in mathematics which says that if the angle between two lines, if the angle between any two lines is theta, okay, if the angle between any two lines is theta, the angle between their perpendiculars also will be theta. So if you consider a line which is perpendicular to this, okay, this is perpendicular, and here again this is perpendicular, so this angle also will be equal to theta. That's what we mean. So if you know the angle between two lines, if it is theta, the angle between their perpendiculars also will be theta. Actually that logic is followed here in taking this angle as phi, because those two lines, these two lines, they are perpendicular to these two planes. That means one is horizontal plane and the other one is inclined plane. So if this angle of inclination is phi, this angle, that means here we marked that phi, this angle also is phi. So the components of what mg, it becomes mg cos phi and mg sin phi. Okay, so that resolution we have studied in the previous chapter, vector resolution. So as per the vector resolution, this component is mg cos phi and this component is mg sin phi. So the component of force which tempts the body to slide down the inclined plane, it is mg sin phi, which is acting along the inclined plane down the plane. Okay, so this body is only what tempting the body to slide down. So when this force comes into action, naturally the opposing force comes into play. That means the frictional force. So that frictional force, it is actually Fs. So we know as we increase the angle of inclination, so if we start from phi equal to 0, you understood, I think, that is phi equal to 0 means what? There is no inclination, and slowly this inclined plane is raised so that phi increases, and as phi is increased at a particular stage, suppose a value is reached for phi, so that the body just starts sliding. Here when we mention that word just start sliding, it means that It has not started sliding, but it's about to slide. Means the static friction has become maximum. So when the body just begins to slide, when that statement is given, it means that that frictional force is maximum and still the body is in equilibrium. The body which is resting on that inclined plane is in the state of equilibrium. So as we know, if an object is in the state of equilibrium, the forces acting on the object, they should be balanced, or we can say that the net force acting on the object should be equal to 0. So another way of stating that condition for equilibrium is this: component wise we say. That means the components in each direction should be balanced. If we have horizontal component and vertical component, we say that the components in horizontal direction should be balanced and the components of the forces in vertical direction also should be balanced. But here, as you know, here we have resolved into two components in such a way that we have components of force parallel to the inclined plane and perpendicular to the inclined plane. So when we reach that maximum static friction state and the body continues to be in equilibrium, we can write the conditions of that equilibrium. That means forces along the inclined plane. This is what we mean by along the inclined plane should be balanced, and the forces perpendicular to the inclined plane also should be balanced. So first let's take the forces which are acting along the inclined plane. So along the inclined plane, we have two forces, mg sine phi acting downwards along the plane, and Fs max, that is the maximum static friction, which is acting in the opposite direction, up the plane we can say. Okay, so when the body is in equilibrium, we can say that these two forces are balanced, means they are opposite in direction. As we know, they are equal in magnitude also. That means they are equal in magnitude. So we have that Fs max is equal to mg sine phi. See, in these topics, no, writing the force equations are very important. You should know how to write the force equation. See how we got that equation. Okay, so that is very important. Mg sine phi equal to Fs max. So that is the first equation. Now coming to the second equation. To get second equation, we have to apply the condition of equilibrium in a direction perpendicular to the inclined plane. So we have the two forces, that is R, that is normal reaction perpendicular to the plane upwards, and mg cos phi opposite to it. So since the object is in equilibrium, both the two forces are equal in magnitude, or we can write R is equal to mg cos phi. So we have two equations, one is mg sin phi and the other is mg cos phi. So we just divide equation 1 with equation 2. So right hand side mg sin phi by mg cos phi. As you know, mg will get cancelled and you have sin phi by cos phi, which is tan phi. So right hand side is tan phi. Now coming to left hand side, Fs max by R. You know what is Fs max? Fs max is nothing but what mu s into R, where mu s is the coefficient of static friction and R is the normal reaction. So this Fs max by R means mu s R by R. That means it becomes mu s. So we have the equation by dividing the two conditions for equilibrium, we get mu s is equal to tan phi. So here mu s is the coefficient of static friction and phi is the angle of repose. So don't get confused. In the previous discussion we had angle of friction and here we have angle of repose. Now we move on to the next topic, that is advantages of friction. These topics you are familiar with already. You know, the friction enables us to walk without slipping. These are the experiences from our daily life. Friction enables the car to move on a road without skidding. So for all motion. That means whenever we consider that motion, no, when we walk, when we run, when the animals run, in all the cases actually it is friction which help us to move. Even the vehicles, actually the vehicles, they are exerting force, okay, and from the friction, as we get the friction from the road, we are able to move forward or walk forward. So it is that friction which enables the car on the road to move forward. Now friction enables us to write and draw on the paper. You just imagine an extremely soft surface or smooth surface. Will you be able to write? No. The tip of the pen will slip on that surface. We won't be able to write. So it is friction which enables us to write and draw on the paper. And friction enables us to light a matchstick. So many uses this friction is having. At the same time, there are many disadvantages also. Friction wears away the soles of our shoes. We know the chappals, the shoes, the footwears, what we use, no, it get worn after using for 1 or 2 months. That we really experience. The tires of vehicles wear out gradually due to friction. These are all what we have direct experiences from our daily life. Friction wears out the rubbing machine parts, okay, and friction wears out the brake pads of vehicles gradually. So in short, no, actually friction always causes wear and tear. That's what we usually say. Friction causes wear and tear. And friction produces heat which may damage the machines. This is usually observed between the moving parts of a machine or something like that. And you know, actually in the primitive men, that means we say no, primitive human beings, how they produced fire by rubbing the stones, isn't it? So that rubbing also is that what the evidence of that friction. So it's due to that friction, when we rub the two stones against each other, no, the sparks and the fire will be produced. So friction produces heat which may damage the machine. So this is seen in between the moving parts of machines. So there it comes as an what a thing which is not at all desirable. And friction slows down motion also. In the case of friction exerted by the air, and in the case of what ships and all, know, when they sail through water, so that water resistance also comes as, actually they are frictional forces, the opposing forces, so it slows down the motion. So actually friction has got both advantages and disadvantages, and that's why we usually say friction is a necessary evil. So friction as a necessity and friction as an evil. What are the advantages and disadvantages of friction? So all the points we have discussed, just go through that. Now, what all methods we can increase friction? We already stated that there are certain instances or situations where friction is desirable. So in such situations, our aim should be to increase friction. So in what all ways you can increase friction? See, spikes are provided in the shoes of players and athletes to increase the friction and prevent slipping. I think you know this what shoes with spikes and all you're familiar with. What is the science behind it? It is to increase that friction. Then gymnasts and kabaddi players, they apply some coarse substance on their hands to increase the friction for better grip. I think you are familiar with this thing. Okay. And not only this, you know, the rainy season, in front of our house and all, where the concrete and all it is there, no, there it may be slippery. You might have experienced it because of water. It become what slippery. So what usually we may use what bleaching powder and all that we can use. uh, Above that, you might have seen your parents doing like this. That means they will be putting some sand there, or soil, loose soil or sand. They will be keeping on that floor where it is slippery. And when the rain settles, no, we can remove that soil or that sand. then you can use it as usual. So to avoid that or to overcome that slippery nature of the surfaces, we can add some soil or sand on that surface. So these are the main methods of increasing the friction. And treading of tires is done to increase the friction, and sand is thrown on tracks covered with the snow. All these methods are to increase the friction. Now there are certain situations where the friction comes as not desirable, it's not desirable. So in such situations our aim should be to decrease friction. So how can we decrease friction? First of all, we can make the surfaces very smooth. It can be done by polishing or by applying lubricants. I think the word is familiar to you. You have heard it in lower classes itself. Lubricants means oil or grease, and even graphite is used as a lubricant. Graphite, which is an allotrope of carbon, it is a solid lubricant. Graphite is a solid lubricant, and even air also is used nowadays as lubricant. Air. So lubricants are the materials which decreases friction between two surfaces. So what semi-fluid what lubricants are there? Oil and grease, and solid lubricant is graphite, and air also can act as a lubricant. Now friction, another method of reducing friction, especially in machineries and all, it is the use of ball bearings. So between the moving parts of machines, we can use ball bearings. So ball bearings, how it reduces friction is this: because ball bearings, they make use of rolling friction. Because of their shape, it make use of rolling friction, and we have already discussed rolling friction is much less than sliding friction. So in that way, that friction can be minimized in machineries and all. So by polishing, by lubrication, and by streamlining, that is applicable in the case of vehicles which pass through air. That means to reduce the friction due to air or air resistance, we can have the special shape of that aeroplane and all, the even the helicopter, all those shapes, that shape we call as streamlining. Okay, so these are the methods of reducing friction. So with that, we conclude today's session. Thank you.